right, everybody. So today we're going to get into some real geometry. So we're going to be looking at some different theorems and postulates that can be used to prove that triangles are congruent. So first we're going to start with some definitions. I already used two that are probably, you're like, huh, what's that? And then we're going to go through a few definitions and then we're going to use them. So the first thing that I said is we were learning about some postulates and some theorems. So that first word there is postulate. And the second word is theorem. And what postulates and theorems are they're basically statements about mathematical or geometrical fact within shapes or within um, where sometimes you're going to have parallel lines and a transversal, or you might have some triangle with lines going through it. So postulates and theorems. So postulates are things that are just accepted as true. So there are going to be these mathematical statements that are kind of the most basic form of mathematical reason, and they are accepted as true. You don't have to prove them, they just are what they are. And so some of these statements down here are going to be postulates. Now, the next ones are theorems, and theorems are generally accepted as true. They are important statements, but theorems technically have to be proved. So, one of the things that you are sort of getting out of during this online school is having to write two-column proofs. I'm going to give you some resources for them. I'm going to do some examples of them, but they really are hard to truly work with from afar, and we don't have time if we're going to get through all the content. But postulates and theorems are what are used in two-column proofs to prove that some geometrical reality is true. So a lot of what this unit is using mathematical reasoning to say why something that you already know is true is true. So the first theorem or postulate that we're going to be looking at is one called side, side, side. And all of these are used to describe whether two triangles are congruent. So when we're talking about side, side, side here, this is a postulate. And what I'm going to do is we're going to put the definition. So what the definition says is if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. All right, so again, that says if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So side, side, side would look like this. Here's your first triangle. You've got one side here that's congruent to another side here. We've got another side here that's congruent to another side here, another side here that's congruent to another side here. Because I know that all three sides of these are congruent to each other, I know that I can say that these two triangles are going to be congruent. So that is the side, side, side postulate. All right, so I think that maybe I can type in this. We're about to find out. Oh, no, maybe I can't type in this. Oh, yes, I can. This is going to be exciting. All right, so the next one that we have is called the side angle side. And the side angle side is also a postulate. So if you can fill that in, that is a postulate. And this is what side angle side says. Side angle side says if three sides of one triangle are nope, that's side, side, side. Sorry. what side angle side says, if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So again, if the two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So go ahead and pause and get that definition down. All right, so again, this one is a postulate, and I'm going to show you what that means in an image because we have that phrase there, included angle, and that might be a new phrase that we don't know. So let's say we have one triangle here, we have another triangle here. So it says if two sides and the included angle of one triangle. So let's say that we have this side and this side. Well, if these are the two sides that I have, the included angle is this angle here. And it's called the included angle because it's the one that's created by the two sides that are given there. So this right here is what it would look like if you had two sides that were congruent, or two sides and an included angle. So this is two sides and an included angle of one. Now, if I had given you this angle, that wouldn't be included because I don't know this side length. And again, if you'd give me this angle, that wouldn't be included because I don't know this side length. Well, what I can say here is that if this one, let's say I now have this, well, these triangles would have to be congruent because what it says here is I have a situation where I have two sides that are congruent, and then I also have their included angles that are congruent. So that's single arc, and each one of them means that the included angle is congruent. So this would be an example of what side angle side looks like. All right, so the next one that we're going to work with is called hypotenuse leg. And something that's important to know about hypotenuse leg is that it can only apply to a certain type of triangle, and that should make sense to you because of what the definition of a hypotenuse is. Okay, that's fascinating. All right, so hopefully while I have been doing this, you have been thinking about what a hypotenuse is, and you know that a hypotenuse is only in a right triangle. So, all right. So when we are dealing with hypotenuse leg, we have a situation where it says if, oh no, that did not go in there. There we go, if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and leg of a second right triangle, then the two triangles are congruent. So again, it says if the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of a second right triangle, then the two triangles are congruent. All right, so I'll pause and you can put that down. All right, so let's go ahead and look and see what that looks like here. So let's say that I have this right triangle here, and I have this right triangle here. Okay, don't look congruent, but one of the things that's going to be important in this unit is if the math says it's congruent, then it's congruent. So if the hypotenuse and the leg of a right triangle, so that would be either leg, so the hypotenuse and the leg of one triangle are congruent to the hypotenuse and leg of a second right triangle, then the two triangles are congruent. So this is an example of what hypotenuse leg would look like. All right, so now we are on to angle side angle. So now here we go. So the definition of angle side angle says if two angles, so that's why you have ASA and or angle side angle because you got two angles. If two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So again, if the two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So go ahead and pause and get that down. All right, so in angle side angle, we have that phrase included again, but now it's not an included angle, it's an included side. And that it has the same concept, just like an included angle had to be the one that was between two sides here. Now an included side is going to have to be between two given angles. So let's look and see what that's going to look like. So I might have a triangle here and a triangle here. And an angle side angle, I would have maybe this angle would be given and this angle would be given. And then the only option for where the included side could be would be this one. So here, if I have two angles that are given an included side, and then I'm looking at a second triangle where I have those same two angles, so I know that these have two congruent angles and that the included side is also congruent, I now know that these entire triangles must be congruent based on that information there. So that is what angle side angle looks like. You've got an angle, an included side, and then an angle, and that can be used to prove that two triangles are congruent. So the last one that we're going to look at here is called angle, angle, side. So again, anytime in these phrases that you see S, it means side. Anytime you see A, it means angle. So the last one that we have here is angle, angle, side. So the definition for this one is going to be as such. So for angle, angle, side, we have if two angles and a non-included side of one triangle are congruent, side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. All right, so we're going to look at what that means real quick. But again, that says that if two angles, and that's why you see AA, if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. So right now, I want you to make sure that you have that definition down. All right, so what that looks like, we'll go ahead and put over here. So we're looking at angle, angle, side. So we have two triangles here, and angle, angle, side means I've got two angles, and then a non-included side could be either this one or this one. For this one, let's go ahead and make it this one. Now, I want you to think about this one. This says the corresponding non-included side. So we're going to talk about what that means because that's very important. So it basically, so we have an angle, angle, and then we have a non-included side. So let's say here I have this angle and this angle. Now, the non-included side has to be the corresponding non-included side. So if I'm thinking about which one is the corresponding one, it is the one across from the one arc. So I need to go here and I need to go to the side length across from the one with one arc, and that has to be the side length that's congruent. If this side length were congruent, that would not be angle side or angle side, because that would not be the corresponding non-included side. So I hope that makes sense. So go ahead and get that information down, and then we're going to talk about one more thing, and then you're going to need your Walsh books. All right, so what you might observe as you go through these different theorems and postulates, oh, I forgot to tell you whether they were theorems or postulates at this point. All right, so let's go back and add that in. But one of the things that you notice is that you see lots of different combinations of the letters S and A. And as you were going through these, you probably started wondering whether one combination of those was going to appear. And what never actually appeared is the letters ASS. So there is no AS theorem. And that is actually kind of important, because the fact that there is no AS theorem means that there are two theorems that they always try to throw into things that don't exist. So two things do not exist, and these things that do not exist are angle, side, side, and they might also try to say like side, side, angle. But these ones that are effectively AS theorems don't exist. So do not be tempted to pick things like that when you are dealing with your theorems. If you ever see those three letters right next or in that order where you see the word AS or the word AS backwards, it is not actually a theorem that you can use. It doesn't exist mathematically. It's not because it's a word that you're not supposed to say. It just doesn't exist mathematically. All right, and then finally back to these. Hypotenuse leg is a theorem. Angle side angle is a postulate. And angle side is a theorem. And we're not going to talk a whole lot about that. You know the definitions of theorem and postulate now, but those just are what they are for your information. All right, so now it is time to go grab your Walsh book, and we're going to look at some of this stuff in practice. All right, so you need to go to page 32. Page 32 in your Walsh book. All right, so what these are going to be these are going to be 7 different examples where we're really supposed to go through 3 different steps each time. And the 3 steps that we're supposed to go through when we're looking at these are these 3 steps right here. We're supposed to determine which components of the triangles are congruent, and then we're supposed to determine if this information is enough to state that all 6 corresponding parts of the triangles are congruent, and then we're supposed to summarize our findings. So what this is asking us to do is it's asking us to look at this information and to think about, based on the information that I have, does it match any of those triangle postulates that we have and theorems that we just took notes about right above. So in part 1, where it says to determine which components of the triangles are congruent, what that's stating is that we need to look at each one of the triangles and figure out what parts of them are the same. So right now, I know that RP is congruent to US, and I know that PQ is congruent to ST, and I know that QR is congruent to TU. So when I go to look at my information on my definitions, I see that the corresponding side lengths of each of my 3 triangles are identified as congruent. So when I think about my definitions here, I go to my definitions, and one of them states that if three sides of one triangle are congruent to three sides of another triangle, then the triangles must be congruent. So now what we are able to state here based on this information is that triangle RPQ is congruent to triangle UST because of the side, side, side congruence postulate. So you can't just say, oh, they're the same because the sides are the same. No, the reason that they're the same or the reason that they're congruent is because of the side, side, side congruence postulate. So some of the examples that we're going to look at, we're not going to be able to prove that they're congruent because the information that they give us does not work. So this is called side, 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 because again, you have three congruent corresponding sides on two different triangles. All right, so in example 2, we want to start by figuring out which parts are congruent. So we have a situation where we have that AB is congruent to DE, and I also know that AC is congruent to DF. And I also know that angle D is congruent to angle A. Nope, that should be on that side, that angle A is congruent to angle D. So knowing this information, this is two sides, and this is also an angle. Well, if I think about what postulate this is, I know I can't put an A at the front of this, and I know I can't put an A at the back of this because that makes a theorem that doesn't exist. So the A must go right there. So we have to see whether this is side angle side. Well, in order for it to be side angle side, we have to have two congruent sides and a corresponding congruent included angle. Well, here I notice that angle A is that included angle formed by the intersection of the 1 and 2, and here D is that included angle created there by the 1 and the 2 marks there. So I am able to state that triangle ABC is congruent to triangle DEF because of side angle side congruence. And I think that one is a postulate, side angle side congruence postulate. Is that true? Yep. All right. So that's 1 and 2. Let's move on to number 3. So number 3 is exactly the same situation. It's just given to us in a different form. So they're asking us to determine which of the congruent statements, if any, could be used to show that these triangles are congruent based on this information. Please do not try to do this without drawing this out. That doesn't make sense. So I'm going to draw a triangle here, and I'm going to call it HIJ. I'm going to draw another triangle here, and I'm going to call it KLM. And again, I use those corresponding locations to name them. And now it gives me this information. It says that HI is congruent to KL, so that's this one. And it also says that angle H is congruent to angle K, so that's angle H is congruent to angle K, and that angle I is congruent to angle L. So that's what my image looks like, and I want to start thinking about what information I know. So I know that I have two angles that are congruent, and I also have a side that's congruent. So this could be maybe angle, angle, side, or it could also maybe be angle, side, angle. So let's go figure out what the difference between those two are. So we're looking at angle, angle, side, or angle, side, angle. So when we look up here, angle, angle, side has a side that is not included, and angle, side, angle has a side that is included. So let's go back down to our example here, and we can see that we have so our angles there are corresponding, they're congruent, and we do have that included side length between of HI and KL. So because it is that included side length here, this is angle, side, angle. And so now I'm able to state that triangle HIJ is congruent to triangle KLM because of the angle, side, angle postulate. So again, you want to think about the information that you have there, and then you want to use that to justify whether or not the triangles are congruent or not. All right, so example 4, similar to example 3, we're going to analyze some triangles here. So we're going to draw two triangles, P, Q, R, and S, T, U. So it tells us that PQ is congruent to ST, that PR is congruent to SU, and that angle Q is congruent to angle T. So what they've given us there are two sides and an angle. Well, we know that this doesn't exist. We know that this doesn't exist. So we need to see if this is side, angle, side. Well, let's think about side, angle, side. In side, angle, side, that A has to be included. So it has to be an included angle. So if we look here, we have a side, and then we have a side, and then an angle. We don't have an angle that's included between two known sides. So again, same thing here. We have two congruent sides and a congruent angle, but that angle is not the included angle between the two given sides. So because this is not side, angle, side, we cannot prove that these two triangles are congruent based on the information that we have. So we cannot prove they are congruent. Now, here's the important thing. We cannot prove that they are congruent, but we also cannot state that they're not. The fact that this does not fit side angle side or any of our other theorems or postulates here does not mean that they are not congruent. But what it does mean is that I can't state that they necessarily are. So stating that something is, stating that you can't prove that it's congruent doesn't automatically mean that it's not. So I hope that that makes sense. But for this one, you would say you would not be able to prove congruency. So we're going to look at number 5 here. And in number 5, we look at two figures here that are overlapping. And that can be frustrating for some people. So one thing that I kind of recommend doing is just drawing these actually separated out. So what you actually have here is you have a B here that goes with D, and then down here is A. So this is BAD, and then over here, you're going to have C up here. This is E, and this is F. So now start filling in what you have. So you know that angle B here is congruent to angle E. You know that angle A is congruent to angle F. And you know that BA is congruent to EF, which is over here. So when I go to look at these, what I have is I have been given two angles, right? And I have also been given a side. So if I think here, there's angle, angle, side, which would be the same as side, angle, angle. So there's no reason to flip it. Or this could also be angle, side, angle. So let's go look at the differences there between angle, angle, side, and angle, side, angle, and figure out what we've got going there. Because these could be congruent, they could just be flipped over, like a reflection of it. So let's go look up there at our rules. All right, so angle, side, angle. And angle, side, angle, what you should notice there is that the side is included, right? And an angle, angle, side, the side that you're given is corresponding, but it's not included. So let's go back down to our example here, and I can tell that this side is included. So this here is an example of angle, side, angle. Now, when you go to state the congruency here, you want to be careful here. So I'm going to do BAD. So that's from the one arc to the two arc to no arcs. So I'm going to state that triangle BAD is congruent to triangle. So that's one arc to two arc to no arcs, right? One, two, no, one, two, no. So to triangle EFC because of angle, side, angle theorem. So again, these ones are going to be congruent because of angle, side, angle. All right, so on number 6 here again, we have some overlapping triangles. So let's go ahead and unoverlap them. So it wants to know whether ABC and DEF are congruent. So again, let's just take them apart here. So we're going to have ABC. It doesn't matter. Wow, that was fascinating. It doesn't matter how you draw them or where you draw them as long as you fill in the information correctly. So A, B, C, D, E, F. All right, so angle A, don't tell me anything about it. Angle B has two of these in it. Angle C has one in it. Oh, that's what's happening. Okay, sorry, my mouse is going rogue. So, and then I also have the side length from A to B. So that's that side length here. So what I'm given here is two angles and a side that is not included. So what I have here is, if this is going to work, what I have here is two angles and a non-included side. So that's not in the middle, so that would be a non-included side. So let's go see what I have with DEF. So with D, with this triangle here, D, they don't give me that, but they give me that the line between DE has one here, this here has two, and for F, I'm supposed to have one angle. And here I have two congruent angles here. So this would be angle, angle, side. And now what I have to see about this side here is whether it's the corresponding side. And here the side is across from the single arc angle. Here the side is also across from the single arc angle. So this is a corresponding side. So what we are able to state here is that triangle ABC is congruent to triangle DEF because of the angle, angle, side. Wow, that's not how you spell angle. Angle, angle, side, congruence theorem, maybe. All right, angle, angle, side. So again, you got to think about whether or not that side is included here, and because it's not, you have to make sure that it's corresponding, and it in fact is. So what we're going to do here is we are going to move on to our last question here. All right, so this is the same thing here. We do have a right triangle, so that's something to think about. But again, we have overlapping triangles, and anytime I have overlapping triangles, I'm going to draw them out as their own triangles. So I'm going to draw this one out as A, and I'm going to draw this one out as DBC. So again, I do have two different triangles here, and I'm trying to figure out if ABD is congruent to CBD. So I want to know if ABD is congruent to CBD. So what we know here is that we have an angle that is a right angle. And we also have a situation where it tells us that AB is the same as BC. And then another thing to pay attention to here is that BD is on both of these triangles. So BD obviously has to be congruent to BD. So what we have here is we have a situation where we have two sides, and we also have an angle that we know is congruent. So really, this is looking like it might be, well, this isn't allowed to exist, right? Because that's not a theorem. If you flip it around in the other order, it would be ass, and we know that's not real. So our only option at first is to think that maybe this is side angle side. If I'm given two sides and an angle, my only option is side angle side. But in side angle side, that angle has to be included. So this one is not side angle side. That doesn't work here. If this were side angle side, it would have to tell me that this angle was the same as this angle, and it doesn't tell me that, so I can't use that reasoning. However, some of us are now recognizing that what we do know is that this is a right triangle. And when you have a right triangle, if you have one leg and a hypotenuse, right? So you've got one leg and a hypotenuse that are congruent, and this only works in a right triangle because of the words hypotenuse and leg. So if you have one leg and one hypotenuse that are congruent to one leg and one hypotenuse of another, then you can use the theorem that only works with right triangles, which is called hypotenuse. That's, wow, I don't even know what I was trying to write, which is called hypotenuse leg theorem. So anytime you're looking at a right triangle, be very careful that maybe you're looking at hypotenuse leg. So the last thing that's going to go with our notes today are these 8 examples right here. So what you're going to do here is you're trying to prove for each one of these whether ABD is congruent to CBD or ABC. So again, these are all examples of which ones you're trying to prove based on different theorems. So what I recommend you do is you draw these out and don't try to think about them while they're overlapping. That's going to be overwhelming. So what you need to do right now is you need to pause the video and you need to go ahead and do those. This is not the homework, this is part of your notes. So go ahead and pause the video and complete these, and then what's going to happen is once you're all done, you can play the video and you can see all the answers of them. If you're confused, I'm going to go through them. If you're not confused, you can just race through and make sure that you got the right reasoning. All right, so again, what you should do when you start any problem to eliminate confusion for yourself is draw out the triangles that they're asking you about and then transfer the information. So it gave me angle B, it gave me angle D, it gave me CD, it gave me AB, and it also had BD, which is part of both triangles, so I know it has to be the same for each one. So when I look here, what I'm given here is I am given two sides and an angle. It can't be that because there's no as theorem. So I have to see if this is side angle side. Well, in side angle side, I would have two sides that are congruent, and then the included angle is congruent. And that's exactly what I have. So I can prove congruency here through side angle side. All right, so what I've already done here is I've transferred this information into the two triangles that I've pulled apart and wrote according to the things that I'm analyzing here. So what I see here is that for each one, I'm given two angles, and I'm also given a side. So angle, angle, side exists, and angle, side, angle exists. Well, an angle, side, angle, the side has to be included. Well, so that would be that side there. That's not the side I'm given, so it's not that one. For angle, angle, side, I have to make sure this side is the corresponding side. So when I go look here, the side that I'm given is across from the single arc angle. Here, the side I'm given is across from the single arc angle. So that is the corresponding side. So I can prove that these are congruent through angle, angle, side. So I hope this process makes sense. If you got these wrong and now it's making sense, you should repause the video and then you should go back and redo them because this is a really important concept in terms of geometry. All right, so here what I've done is I've again taken the information, transferred it into these two triangles. What you might have noticed is that I did indicate that angle B is a right angle. And the reason that I did that is because angle B is right here, and I know that the angle next to it is a right angle formed by these lines, so that also has to be a right angle. So some of us might be tempted to pick hypotenuse leg because we're looking at a right triangle, but they don't tell us anything about the hypotenuse. What they do give us are two sides and an angle. Well, we know this is not real because ask theorem's not real, so I need to think, can I put the angle and make it included? So is this side angle side? Well, if it's side angle side, you have a side, an included angle, and a side. Well, that's exactly what we have. We have a side, an included angle, and a side. So these are congruent. These right triangles are congruent according to side, angle, side. All right, so what I've done here again is I've separated these two triangles out. The part that might have been confusing here is this BC piece. Well, it tells us that B is this part up to this intersection is congruent to here, and that this part up to this intersection is congruent to here. So these entire lines here are congruent. So we've got that there. So when I go to look at this, what they've given us is they have given us two congruent sides and an angle. We know that theorem doesn't exist. So I want to look and see, is this side angle side? So if this is side angle side, the angle has to be included. Well, this angle here is not an included angle. This would be the included angle. This is also not an included angle. It would be here. So I can't use this theorem. I can't use side angle side. There's nothing I can do with these two side lengths and this particular angle to prove that these are congruent. So this one cannot be proven. So if you got that, that's very clever. This cannot be proven. All right, so for this one, I've separated the triangles out. I knew that CA was the same as FB, so I've got that indicated. I know that AE was made up of two single tick marks and that BD was also made up of two single tick marks, so those are identical. And then here I've got that CE is one piece plus this DE, and then this length here, DF, is one tick mark plus the same DE. So since it's made up of one tick mark each, or this piece here that's identical plus this identical part of this triangle, we know that those have to be the same. So at this point, what they've given us is three congruent sides on corresponding triangles. So what we have here is side, side, side to prove that these triangles are congruent. So again, think about how that overlapping piece matters. Like in this next, in this next one, like this side length here, BD, is made up of this identical piece and CD. Well, EC is made up of CD and a double tick, so I already know that EC has to be the same as BD. So those are the things, and like this one, AD is made up of a triple and a single, well, FC is made up of a triple and a single, so those are congruent. So think about those things. We can't say anything about AB and FE, but there's lots of things that you can say because of those overlapping pieces. All right, so when I actually take these two triangles and redraw them and reconstruct them, I end up with a situation where I am given two sides and an angle. Again, that's not a thing, but I want to check and see if this is side angle side. That would be a side, an included angle, and a side, which would be corresponding with a side, a congruent angle, and a side, and I do have that. So the angle 6 relationships are proved by side, angle, side. Only got two more here, and then we'll move on to the homework. All right, so on this one here, when we start looking at this, we see that we have two sides and an angle. We know that's not a thing, so we start to look for side angle side. That would tell us that your angle given would have to be the included angle, which would be the one up there, so that's not going to work. So now there's one more thing I need to think about here, which is the fact that this is a right triangle. So if this is a right triangle, which it is, if the hypotenuse and a leg are congruent to the hypotenuse and the leg of another, we're looking at congruent triangles. And when I look here, DB is the hypotenuse, AE is the hypotenuse, and they are indeed congruent. And then you are also given a congruent leg for each one. So these triangles are going to be congruent according to hypotenuse leg. All right, so for this next one, when you actually go separate those triangles out, you get here angle A each has the double arc. We have angle C each has the single arc. And then AC is actually a part of both triangles, so it has to be the same length. So what we have here are we have two angles and a side. So we could have, well, it's not called side angle angle, it's called angle angle side, or we could have angle side angle. Well, the difference between the two here is the location of the side. So an angle side angle, the side is included, and an angle angle side, the side is not included. Well, I have an angle, a side, and then an angle, a side, and then an angle. So I have an included side there. So here I'm going to say that these are congruent because of angle side angle due to that included side. All right, so your homework over the weekend is going to be two things. One of them is going to be right here in the Walsh book, and then the other one is in Delta Math, and it's exactly these different things here. And if you go to Delta Math, it's already published, so you can start working on that whenever. But again, this stuff will be due Monday morning because that's our next school day. But what we have here in each one of these, you're just going to, based on these images, determine whether you can prove congruency using one of the different rules or whether or not you cannot prove congruency. So these should be pretty straightforward. They're just like the notes. Please remember to draw pictures here before you try to make a statement there. And again, so same things. These are just asking you to analyze these triangles based on the information given and the different rules that you've learned. Are these congruent or not? And in order to state that, you have to use one of those rules that you spent a lot of time today learning about. So that's one of your assignments. And again, of course, I'll make a video of the solutions to this so that you can check those on Monday before you are looking at your next assignment. And then again, your Delta Math, it'll kind of help guide you through that as you have questions. But again, it's just going to give you two different images and it's going to ask you whether or not you can prove congruency and based on which statement. So it's going to be a lot like this, except it's on the computer. So go ahead and get started on that work when you are ready. This is one of the more important things that comes up in geometry. We're going to be using these quite a bit, these units, so make sure that you become familiar with these phrases. All right, talk to you guys later. Bye.